Hi, this is Kevin Trainer. Welcome to my tutorial on the coding exercises associated with the Zelle textbook, Chapter 3, Computing with Numbers. And the assignment that we have is to do 11, 12, 13, and 14. And so I'm going to begin with number 11. And again, I'm going to do something close to what the problem is to get you an idea about how to solve this kind of problem. This is part of my see one, do one, teach one approach. I am going to ask you, this is a change from what we've done in past weeks. Before you start seeing what I do in my tutorial version, pause the recording and just say, now let me sketch this out. Let me think about this problem. Can I sketch out some pseudocode for how I would solve it? Okay, and then play what I do. See how close we are. Okay? Start testing your ability to recognize problems and kind of set them up. Okay? I don't want you to be so depending on me setting them up that when you don't have that, you feel at a loss. So just kind of pausing and guessing ahead will do just fine. Okay, and then when you're ready, play the tutorial, and you get all the benefit. Plus, you'll have given it the setup of the problem a try on your own. Okay, here we are. We're doing number 11. I'm working in my host operating system on my regular old copy of PyCharm Edu. So I'm not going to be calling the project the exact same thing that you would call yours to hand it in, because I already have one of those and I've already posted that up in this copy of things. So I called this one Zelle Chapter 3 Tutorial. And of course, for exercise 11, I'm just going to call it what you would call it. I'm going to call it Chapter 3, Exercise 11, even though it's not the real exercise itself. It's a tutorial for it. Okay, and so I have that, and that's looking good. And then I've got to decide what I'm going to put in here. So if we look at what the real question for exercise 11 is, it's write a program to find the sum of the first n natural numbers where the value of n is provided by the user. So this whole n as a proposed number, it's kind of an expression that we use from algebra, and we use it when we're trying to set up these kind of exercises as well. So the user gets to choose the number n, and then we're going to sum up the first n natural numbers. And I want to remind you that natural numbers are just integers, so they're whole numbers, and they start with 1. They're the numbers that we use for counting. That's why they call them natural. Those are the ones that we naturally use when we enumerate things and stuff like that. So instead of doing exactly that, I'm going to do something pretty close to it. I'm going to have you sum up a series of the natural numbers, but I'm not going to have you sum it up from the beginning. I'm just going to take a subset of them, starting with the number n, okay, whatever that might be. It could be 1, but it could be 5, it could be 321, okay? And then I'm going to go on to 7 higher. So I'm going to have you sum from n to n plus 7. So that's going to be different enough from what you're going to be doing that you'll have to think about it a bit. Okay, so what are we going to call the file? Well, let's call it chapter 3 exercise 11.py, and of course I like a space between that comment and there. And what do I want to call this? Well, I'm going to call this sum of natural numbers starting with n and ending with n plus 7. It just so happens I've already typed that out somewhere, so I'm going to copy that because I'm lazy. Okay. All right. Now let's skip a couple lines. I want to do the pseudocode for this with you. Now you can pause here and do your own pseudocode, okay, and then compare notes. I think that's what I'd like you to do. But of course, you're in command of your video player, so you're going to do what you're going to do now, aren't you? Okay, so I need a bunch of comment lines. Now, in some programming language, we have something called a multi-line comment, and you put some kind of a character sequence at the beginning and put some kind of a character sequence in the end. We don't have a proper version of that in Python. They're all single-line comments. So I'm going to take a bunch of lines and try to toggle them into being a comment, and that doesn't work, and that stinks. Okay, well, I tried. Okay, so here's our pseudocode. So first, let's try to identify the major sections of the pseudocode. Well, this I think is going to follow the model as many programs do of input, process, output. Okay, so let's do that. Let's type in input, a couple blank lines, process, a couple blank lines. Oh, it changed my spelling there. Output. Okay, probably I just have to put a space after the word. So process space. Now it won't look anything up. Okay, and that looks good. All right. Now there are some things that we typically do at the beginning of a program that are kind of polite, nice things, and getting things ready and all that kind of stuff. Back in the old days when I learned to program, we called that housekeeping. So let's say before we get into this formal stuff that we have to do, let's get this clean house here and do housekeeping. And that's maybe an old school expression, but it still works. So let's see if we're able to toggle all these into comments. Can we? Yeah, we can. All right, that's not too bad. All right, I like that. Okay, so we got that. So let's think housekeeping. Okay, what are we going to do in there? Well, we're not going to type in all caps. Well, the only thing that I can think of is we're going to print a polite introduction to the program. Okay, print polite introduction. Okay, and we know how to do that. Typically, it's pretty much the same as this comment that we put up at the top. Okay, and this is we're kind of getting used to do that. Let's do it. Okay, now input. What has to be input? Well, the number is starting with n, so we need to get n. Okay, now there's typically two parts of getting something from the user. We typically do it with one line of Python code, but we have to print out a prompt. We have to have some kind of a message that says, give me your such and such. And then we have to read the input. We have to get the input and do whatever we want with it. So let's say this. Let's say that we're going to prompt for n, and then we're going to get n. And oh, well, that's not a That's not a comment, so we're going to toggle it into a comment. And look, it gets my indentation all screwed up. Don't you just love that? So we prompt for n, and then we get n. So now we have n. Okay, and if you really wanted to be detail oriented here, and that code that we use to get in, we really do three things. We prompt, we get in a string version of n, and then we convert it to an integer version of n. We really do three separate things, but let's not worry about that. Well, prompt for n, get n. I think we have the idea. Okay, now we've got process. All right. So I'm thinking that within at the overall input process output pattern that we see here, there's another pattern that is really going to work for us, that we call the accumulator pattern. Okay, and the accumulator pattern is we establish a variable that's going to hold some kind of accumulated total, and we properly initialize that, and then as we go around our loop, but totaling up all the things that we need to total, we just keep adding them into this accumulated total. Okay, and this is a very popular pattern, one that you're going to be using, well, for as long as you program, because it's a solution to a lot of problems. So the first thing we need to do is we have to say, well, we need a variable to hold the result, and the author really likes the variable name sum, but sum is not a really good variable name because it matches one of the built-in method names, and you'll see sooner or later when I show you how to check your code, how to inspect your code with the automatic inspector. That's something that it warns about, using the same name as some of the built-in names. So let's use accumulators. Let's say accumulator, and let's initialize it to some kind of a neutral value. If you're adding the neutral value, the proper starting value for an accumulator that you're adding to is a 0. I think I mentioned the other day, if you're doing a chain of multiplications, you wouldn't want to start with a 0, because anything times 0 is 0. You'd be 0 forever. If it's a multiplication type of accumulator, you want to start with a 1. Okay? So we have accumulator equals 0. Now we need some kind of a loop. Okay, so let's just say, let's create our loop starting with n and ending with n plus 7. Okay, so we're going to have to put some kind of expression in our for loop that gets us that sequence of numbers. I think we can do it with a range. Okay, and then what's the work? We call this the body of the loop. Okay, what's the body of the loop? Well, let's indent it. We want to add the number that we got in. So I guess we want to say, yeah, add the number to accumulator. Okay. Now, a lot of people might say, well, this isn't Python, you know. Well, I'm going to say that in pseudocode, it's pretty liberal. The rules are it's a little bit more like English than code itself. And I think this fits the bill. So we go round and round and round till we're done with the loop, and then we need to output something. So what are we going to output? Well, let's look. We're going to have to print something. So we want to print a message and the accumulator value. Okay. Now, is that perfect pseudocode? Well, it's good enough for Kevin. Okay. Hopefully it'll be good enough for you. All right. So now I just want to turn this into code. Well, where do we typically put our code? Well, we put it in a main procedure. We need to define def main parens colon. Okay. And then we're going to need our code in here. And then down at the bottom, when we're done, we're going to have a call to main. And of course, the call to main is the only real line of code that's not hidden in either a comment or a procedure. Right? Good. This is our typical thing. And it doesn't like main, I think, because there's no code in it yet. Let's put some code in it. Okay? So, what's the first thing that we have up in our pseudocode? Well, it's this housekeeping stuff. Print a polite introduction. Okay. Print some kind of a character string. Let's just go up and find that comment that we had. That's not too bad. Sum of natural numbers starting with n and ending with n plus 7. I like that. Okay. All right. And I kind of like it better if we would say something like calculate sum of numbers. So maybe calculate sum of natural numbers starting with n and ending with n plus 7. Okay, that's good. Okay, how much of your code are you going to write before you test? If it's me, it's just a line or two at a time. Okay, so I'm not ready to run my first test. So I'm just going to go up here and run it. And I get out calculate sum of natural numbers starting with n and ending with n plus 7. I'm good. Okay. All right. Now, how about the code that's going to make this input part of our solution work? Well, we're going to prompt for n and get n. Oh, I know how to do that. So in this case, even though n is a letter, it's kind of a term of art. Okay, so typically a one-letter variable name would not be all that good, but since we've been talking in terms of n, we'll call it n. So n gets assigned. Okay, and then how do we do this? Well, we put one function inside of another. So we put an input inside of an eval. So the eval is what turns it into a number, and the input is what does the prompting and gets the input. And so what are we going to say? Well, let's say enter, let's be nice, please, as big character string, please enter starting number. Okay. And remember, you have to put a space on the end of these because it doesn't get added for us like it gets added on our prints. Okay, so we add a space there. All right. Can I test again? Sure I can. Just going to test again. Please enter starting number 12. Okay, it kind of dies there, but that's fine. It doesn't blow up. That's nice. So that's my input. Now, my process. And you'll see what I've done is I've kind of left a blank line between these groupings in the pseudocode, and that's allowed. I think that's pretty good. It helps us keep track of the different parts. So we have to initialize the accumulator variable. So this is easy. We're going to call it accumulator, and it gets an initial value of 0. That's nice. And now we need a loop. Okay, so now here's where we're going to have to start working. Let's say for I, it's going to be loop control variable. Okay. Well, let's not call it out. Let's say for value. For a value in. Okay. Now, we could just give it, if we wanted to, we could give it a list. We're going to learn about lists in the next chapter. So we could say 1, 2, 3, 4. Okay. And then we would say this. Now, let's do a kind of a cheapy version of it. Okay. And then, okay, so we're going to say accumulator. We want to assign that the value of the current version of accumulator. So the new version of accumulator is going to be assigned the current version of accumulator plus the value. And what's the value? Well, the first time through, it's first value, second, third, fourth. Okay? All right. All right, so we really can't see any what's going on there. But what could we do? Well, we could throw in a print for testing. Print accumulator. And see where we are. Okay? So let's see how that goes. So again, let's run a test. Okay, we're not all the way to the code. This idea that you walk to your solution, I can't tell you how it makes life easier. Well, I just did. So enter starting number. We can put whatever we want here, 333, because we're not paying attention to it yet. And so it went from 1, 2, 3, and 4. So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. And what do we get? Yeah, at each time through the loop, 1, 3, 6, and 10. Okay, so that works about what we'd like it. We're not getting the sequence that we want, though. I believe that we can get a sequence with a range expression. Okay, so how do we do that? Well, let's back up. And let's say we want a range, okay? And what can we can 3 possible variables. We can have the start, the stop, and the step. So the start is the first number that we want, okay? Well, isn't the first number that we want coming in from the user and getting put into n? Okay, n. Okay, comma. What's the second argument? Well, where are we going to stop? Well, we're going to stop at n plus 7. Right? Wrong. Okay? The second argument to range is the first one that you don't want. So the last one we want is n plus 7. The first one we don't want is n plus 8. So let's put n plus 8 there. Do we have to say what the increments are going to be? No, we want it to be 1. We want it to be n plus 1, n plus 2, n plus 3. Keep going up like that. Okay, so let's see how that goes. Now, this n plus 8 looks a little crowded here. So let's give it some space. Looks a little bit better. Now, some people might say, well, that's an expression. I want to surround it in parentheses. You can. You don't have to. I used to all the time. Now, I don't really do anymore. But it's not wrong one way and right the other. Some people like to put the parentheses there like putting on your seatbelt. Well, okay. I'm not going to talk about putting out your seatbelt. So let's look at this. Let's run a test that looks like this. Okay. So enter the starting number. Well, let's say 5. So this looks good. 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. So 5 plus 7 gets us to 12. And then we have to see where we are. So it looks like the answer is 68. Okay, so I think that's working pretty well. Okay, I think we got the sequence that we wanted. Okay, We started with n and we ended not with, and we ended with n plus 7, which means that this second parameter here had to be the first one we didn't want, n plus 8. So that's where a lot of people go wrong, kind of off by 1. All right, so that's good. Now, are these proper values? Well, I don't feel that this is properly tested yet, because let me test it with an easier set of values. Okay, why don't we start with 1? Okay, so why don't we test it here? Why don't we test it with 1? Okay, so we get 1, 3, 6. Let's see if we can do this. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 7 is 28, plus 8 is 36. Well, that seems to be working. Okay, so I'm pretty happy with that. All right. Now, just when I look at this, problem, I see that if it's going to add up one sequence the right way, it's going to work. It's not going to have a problem with another one. I just want to point out that you could tell this to do something that's not within the definition of the problem. Okay, and this is always going to happen until we learn to check the validity of inputs. Like, for instance, even though the natural numbers start with 1, we could say -1 here. Okay, and -1 plus 1 is no, 0 minus 1 is this is where we are. We start with -1. Well, I can't even tell if that's right. All right. The fact is, that's not one of the natural numbers. Okay, so if we had a more robust program, we'd actually check for that. But we're not. But it does work if you did it. We're still relying upon the user to give us proper inputs. But let's see if we've got 2, if it works. 2 plus 3 is 5, plus 4 is 9, plus 5 is 14, plus 6 is 20, plus 7 is 27, plus 8 is 35, plus 9 is 44. That worked fine. Okay. Now, are we done yet? No, we're not done because we don't have output done. We've been printing out, but this is kind of test output. Okay, so let's take that testing that we're doing. Let's take that printing that we're doing and come down here one more line. We still want it to be within main. And let's say we want to print accumulator. Okay, but we want to put some kind of a message first. So let's say something like the sum of these numbers is, comma, accumulator. So let's see how that goes. So that we should not have the repeating test print, and we should have the proper one at the end. So if we say 2, we should wind up with the answer 44. Let's see if we have that. Okay, give it a run. 2, the sum of these numbers is 44. Okay, that looks good. All right. Now, what do we want to do to make sure that the program is in good shape? Well, first of all, while the pseudocode was good, we don't want to leave the pseudocode in the program. Okay? Nobody's going to maintain our pseudocode, believe me. And we usually like to get those 2 skip lines in between program elements. Okay, so that means after our main, we want 2 blank lines there. And we want to be skipping just 1 line between these things that we're trying to separate, not 2. So I think that looks better. Okay. All right. Now, could you put these all together? I think you could. It's a matter of style. Okay. A lot of people think that this style that we see here with the blank lines makes it easier to see the various parts. Okay, and or could you put them all together? Well, it's actually small enough that you could put them all together. It's kind of, well, artistic decision. Okay, every time we change the code, we're going to run a test. So let's run a test. So I'm going to run tests. And I'm going to put in the number 2 again, and we got back the answer 44. That's good. Now I'm going to show you one more way to test the goodness of your program. Okay, there's if we go up to the main menu for PyCharm and click on Code, and go all the way down to the last grouping. The first one in the last grouping is called Inspect Code. Okay. And it's going to say, well, what do we want to inspect? Well, not the whole project. So let's say custom scope, all places. No, let's just say current file. Okay. And what's the inspection profile? Well, it comes with the default, and we're just going to use that. Okay, and it says down here on the right, no suspicious code found. 1 file's process current file. Okay, well, what could we have done? Well, if we don't skip these 2 lines here, okay, syntactically that's okay, but it's not good reading, right? We also want to get rid of all the blank lines at the end. If we don't do that, so why don't we, I'm going to save that, and I'm going to run a test. No, I'm sorry, I'm going to do the code thing. Sorry. So go up to the menu, click on Code, Inspect Code, and you'll see that that the settings in this dialog are sticky. So it sets the current file. I say OK, and oddly enough, it doesn't find any code that it thinks is suspicious. Okay. See if we get rid of those 2 lines. Do it again. Okay. All right. Now, it's got 1 Python weak warning. Okay. PEP 8 is a coding style guide that we'll see in a minute. And it says that we've got that we expected 2 blank lines and we found 0. Okay. So where is that? Well, I guess right up here before def main. Okay. So, if you look over here, you can see the code it doesn't like. You can reformat file, ignore errors like this, or we can change the settings for the profile. We're not going to do that at this point in the class. Let's click on reformat file. And it's funny, now what it doesn't like is it was okay to have the def for main right up here against the comments, but it did want 2 lines between the main procedure and the call to main. Okay, so now it found that, and it solved that for us just with the click of a button. Now I'm going to go a little bit farther. I like my 2 lines up here too. So if I say that I want to do it again, here I can just go out and say code, inspect code, Keep the settings the same. And now it's saying over here, no suspicious code found, one file process, blah, 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 blah. Okay. That's a good way to make sure that you haven't done any bad things. One of the things that we're going to find in doing that code inspection is that it's going to find some places where maybe we have an error hiding in our code. And we'll learn some more about what it can do as the weeks go. So what's PEP 8? Well, let's just bring up the browser here. I got a browser here somewhere. Okay. So let me get a browser and put it in the window over top of what we're currently working with, so you'll be able to see it. And I'm just going to do a search for Python PEP 8. Okay. And PEP 8 is the style guide. And you can just go all the way down through it. It says all the stuff that you should do about how you lay out your code. Okay. So one of the things that that inspector is trying to do is to look for violations of the style guide. Now, it has to do with naming of variables, skipping lines, indentation, all kinds of expressions of programming style. So if it gives us a PEP 8 complaint, it's because it thinks that our code doesn't conform to the PEP 8 style guides. And I'll leave those for you to look at on your own. Okay? So I got a lot of things up here. So that was exercise 11. I'm going to pause here before I start exercise 12. Okay, so now we're back for exercise 12. Okay, so it says, the real exercise says, write a program to find the sum of the cubes of the first n natural numbers where the value of n is provided by the user. Okay, well, that's pretty close to the one that we just did, okay? So what I'm going to do is I'm not going to do the cubes. I'm going to raise them to the fourth power, okay? Not the third power, all right? But I am going to start with the code that we had before. So what I'm going to do is I'm going to take the same sequence that I used for number 11, which is n through n plus 7, which isn't the same one that you're going to do. So I'm going to have a different sequence, and I'm going to raise it to a different power, and that ought to keep you going. So again, it might make sense to pause here and kind of think for yourself. Well, how are you going to go about solving this problem, even before you've seen how I'm going about solving a similar problem? All right, so hopefully you're back. So what am I going to do? I'm going to take this exercise 11 and I'm going to copy it. So I'm going to highlight it, right click, say copy. I'm going to highlight the name of the project, right click, say paste. Okay, and it gives me a chance to change the name. Well, it's not going to be 11, it's going to be 12. Okay, so it's going to be, that's not what I wanted. Let's do Control Z for undo. So I just want to get rid of one character, turn a 1 into a 2. It's always the last thing you try. 12.py. Okay, say OK. And it opens it up there. All right. Well, I know that the comments wrong. So for something like this, where I'm taking a solution I already have and I'm adjusting it, I'm not going to do pseudocode. I'm just going to look at this and say, how many steps is it going to take to walk this to where, from what I have now to what I want to get. Okay, so the same whole approach, the input process output still works. The accumulator pattern still works. Okay, we're still going to be working on the same sequence. Okay, that's good. We're just going to raise it to a power. Pretty much all we're going to do. So we're going to have to change some of the comments and polite messages, and then we're going to have to change some of the we're going to have to change some of the calculation to make sure that we raise the values that we're getting in the values in the sequence to a power, rather than just accumulating them kind of as is. Okay, so let's go at the message first. Sum of the natural numbers starting with n and ending with n plus 7. And I'm just going to put a period there, and I'm going to put in a second sentence. Okay? And I'm going to say each number will be raised to the 4th power before summing. Okay, now that's a little awkward, but not too bad. Okay, so let's see. We've got, I think we've made good changes in our initial comments. So let's go down to our code. It's all in main. So this first polite printing, it's pretty close to what we want. I'm just going to put a period on the end so they look like sentences. Okay. And now I'm going to have another print that's going to say the second line of my comment, because I think that's good. And I'm just going to copy this right out of the comment. What the hey, huh? Okay, that's good. Okay. There we are. So can we test that change? Well, yeah, we could test that change, and we could run this, and we say calculate the sum of the natural numbers starting with n, and each number will be raised to the 4th power before summing. Please enter starting number. Okay, I'm just going to stop there. Okay, all right. I've tested. I tested my polite message. I've tested my prompt. That still works. Okay. Now let's come down in here. We've got accumulator equals 0. Well, that still makes sense. We're still going to be adding something. Are we going to be adding exactly the values from this range? Well, no, we're going to raise them to the 4th power. How can we do that? Well, let's try it by brute force initially. So how do you raise something to a higher power? Well, you multiply it times itself. So what if we come up with something that says value times value times value times value. Okay? So this is 1st power squared cubed 4th power. All right? I think that'll do it. Okay. And then look at the message. The sum of these numbers is that. That's okay. I mean, they are numbers. This is kind of a general message. I think that would be okay. And we still have the answer in accumulator. All right. That looks pretty good to me. Let's give it a test. Okay. We got the proper messages. Well, let's just start with 1. Okay, the sum of the numbers is 8772. Okay, how are you going to test this? Is 8772 right? Well, I tell you what we could do. We could we could get out a pencil and paper, and we could write all these down. We could write out the sequence from 1 through 8, right? And then we could somehow raise them to the 4th power with our calculator, maybe by multiply, and then we see what we get. Okay? Or we could add a little code for testing. Okay? And what would that be? Well, let's print the accumulator at each step. Okay? In fact, at each step, let's do the following thing. Okay? Let's print let's print n. Oh, I don't think we said that. I think we said for value in the range. So we want to print value, and we want to print the accumulator. Okay? So again, we're going to put in a little test print here so that we'll see the numbers and we can test them as we go along. Okay, so let's see how that goes. Let's give that a run again. Okay, let's start with 1. Okay, so ooh, that's not what we want. I think what I wanted was I wanted the value, and the next thing I wanted was the value raised to the 4th power. So I want 3 things here. So right now we're raising it to the 4th power by saying value times value times value times value. Okay, so let's give this a run. Start with 1. Oh, okay. So now we can see how it goes up. So let's look at the raising to the powers. Is that working okay? So 1 to any power is going to be 1. 2 to the 4th power, is that 16? Well, 2 to the 2nd is 4, 2 to the 3rd is 8, 2 to the 4th is 16. That looks right. So let's just test a high one that makes sense. Let's do the last one. Well, how could we do that? Well, let's just get a calculator out. Oh, that's not what we wanted. We wanted, I don't know what's happening on your screen, but I'm starting up my calculator. And my calculator is, there it is. It's on the other monitor. So let's bring that over. You should be able to see it. Okay. And again, I don't see an easy way to do anything but just brute force multiplication. So 8 times 8 times 8 times 8. So clear it to make sure it's clear. 8 times 8 times 8 times 8 equals 4096. All right, that looks good. Okay, and then let's just look if we're accumulating the right way. So we start with 1, 60 more is 17. 17 and 81 is 98. Well, that makes sense. Now I can't do them in my head that well anymore. So 98 and 256. Let's just look at that. 98 plus 256. 354. That's good. And then let's just do the last one. 4676. 4676 plus 4096. 4096 equals 8772. And that's the answer we're getting. So that's working fine. All right. So I'm going to pull my calculator off of there. I think I've got it pretty well tested, provided when I'm taking out my test code, I don't injure it. Okay, so do I want to keep this test print? And I'm going to say no. Okay, this is just test code. Typically when you're done with test code, you get rid of it. Okay, that kind of test code. All right, so let's run it again to prove ourselves that we didn't accidentally change it. So let's give it a run. Have it start with 1 this time. 8772, that's what we were looking for. That's great. Okay, now I'm all with this except that this value, this isn't grown-up programming. Okay. Typically, when you raise things to a power, first of all, it's not good documentation. You have to be able to count them with your eyes. Okay. It would be better documentation if we were to use some kind of a function that could raise a number to a certain power. Whoa, maybe we could use the math module for that. Okay, I bet there's something that raises something to a power. So let's go find that. Let's go out. We're going to open up our browser here somewhere. It's hiding on me. There it is. Okay. All right. And typically what I'm going to do is I have a home page that I go to as all my popular links, and I haven't changed it since last summer when I was teaching this with Java. But I've got links to all the Java documentation. I've got to add in the next week. I'll change this page and put the Python documentation in. So where is the Python documentation? So remember, it's at docs.python.org. Okay, and we want the library reference. Okay, and then we want to go down and find numeric and mathematical modules. We want to find math. Okay, and let's see, number of theoretic and representation functions. Nope. Power and logarithmic functions. Okay, that looks good. A lot of times you'll see this exp and you go, oh, that's exponent. Well, it's not. This is e to the x. This is Euler's number, so it's not what you want. But pow is what you want. Math.pow, and it takes two arguments, x and y. Return x raised to the power y. So the exponent comes second. Okay, great. Let's just tear this out of here. So you would think that what you could do is you could come right down in here and you can say, okay, we're not going to need all that value. We're just going to have value, comma 2 is going to be the argument. Value, comma 2, comma 4, raise it to the second power. X is value, y is 4. And then we have to use math.pow. Oh, doesn't work. Why? Well, I never told it that I was going to use things from the math module. So we have to do two different things. First of all, we have to use the right expression when we want to use it. Use the name of the module dot the name of the method. But then up here, before all of our other code, we want to have an import. So let's just say import math. And a little underline that says we have an error goes away. Okay, so this is much better documentation. It's a much more general solution. More grown up. Okay, and it's already saved. Let's give it a test. And again, let's ask for 1. And it's going to give us 8772. Now, interesting look at that value 8772. All of a sudden this says .0. So as you remember from the data types, what we've been using all along is we've been using ints, and now all of a sudden it's coming back as a float. Well, why is that? Well, because that's the type that gets returned by the function pal. Okay? Well, if you really think of this in terms of our problem, okay, the way we stated the problems, we're working with natural numbers. A natural number, an integer raised to any power, will that ever have a fractional part? Well, it turns out not, because you're simply multiplying it times itself, right? And if it doesn't have a fractional part to begin with, it's never going to get a fractional part. So you kind of go, do I really want to be printing an answer that shows fractional parts? Well, not for this problem. So how can I solve that? Well, I can do one of two things. I could do it by rounding. Okay, so I could say I want to round accumulator. What? I want a left paren here and put that on the end. Okay. Okay. So round, not rounded. Round. All right. So it likes that. Let's give that a run, and let's input a 1 again. Okay, 8772, no 0.0, that's good. Or, even better documentation would be to use the function that is also built in like round. It's called int. Just convert it to an int. Okay, that essentially does the same thing. So I kind of like that better, so that's the one I'm going to leave in there. So, again, before I printed it out, I converted it to an integer. So I give it 1. Now it says that some of these numbers is 8772, and there's no fractional part, which, given the nature of the problem that we have, probably fractional parts is just going to look odd, okay? Because we're always expecting that to be 0. And that about does that. Let's take this code and let's check it. Let's run the code inspector on that. So I'm just going to go up to the menu, click code, inspect code. I don't want the whole project, just the current file. And let's see what it doesn't like. Oh, this is interesting. It says assignment can be replaced with an augmented assignment. Let's take a look at that. Let's click on that. And so it's interested in this accumulator equals accumulator plus math_pal. So there's a shorthand version for this x equals x plus 1. You can say x plus equal 1. Okay? And some people think that that's better documentation. In some versions of the interpreter, it runs a hair faster. So I'm not going to hold you to doing this, but if you want to make this tool happy, well, you say, okay, give me the augmented assignment version so that we get to replace. So click on replace. And what does it say? It says accumulator plus equal math_pal value 4. Okay. Now I've got to say that long ago when I first saw this, I guess I saw it in C first, but I used it a lot in Java. I thought that this shorthand was unnecessary. I've really come to like it. So I like the plus equals. And Python coders tend to favor it. Okay, and I think that's probably why the code inspector tends to favor it. Okay, so we made that change. Just if we run the code inspector again, we should get no complaints. So current file, no suspicious code. Okay, pretty cool, huh? I'm liking it. And oh, we did change the code. Let's run one more test. Run the test. Let's give it 8772. And we're all done there. Okay? So the version that you're doing's a little different, but you get the idea. All right? So I'm going to pause before I go on to 13. I'll be right back. Okay, well, we're back on exercise 13. The real version says, write a program to sum a series of numbers entered by the user. The program should first prompt the user for how many numbers are to be summed. It should then input each of the numbers and print a total sum. So I'm going to do something like this, but I'm going to actually jump ahead to the next chapter, and I'm going to do a little bit of work with what it would be like instead of accumulating integers. Okay, what if we were to try to accumulate character strings? What would be the character string equivalent of accumulating? Okay. And it turns out it's something called concatenation. Okay, so if you have two variables that hold character strings or references to character strings, however you want to say it, and you say, and one is A and the other is B, and you say A plus B, if they're character types, instead of trying to turn them into numbers or something like that, what it does is it will append them to the character string. Okay, it'll put them in. So if you say A plus B, you get a character string A and character string B just glued together. That's called concatenation. So we're going to do that. So we're going to prompt for how many character strings, right? And then we're going to get them in, and then we're going to accumulate them into one character string accumulator, and then we're going to print out the accumulated character string that's been concatenated together. Just to go through the accumulator pattern again, but just see how it would be different if we were to use character strings. The real one that you're going to do is going to be working with integers, so it's going to be easier, but there you go. So let's create a new file, Python file, and let's call it Chapter 3 Exercise 13. Okay. And let's put in a comment and say Chapter 3 Exercise 13.py. Okay. And what are we going to use for a comment? How about concatenate? When you put one character string, when you attach it to the end of another, it's called concatenation. So concatenate a variable number of character strings entered by the user. Concatenate a variable number of character strings entered by the user. Okay, how does that look? All right, that looks good to me. And that's about the way that people would express it in kind of programmery shop talk. Okay. So let's do some pseudocode again. Okay, so let's start with housekeeping. Input, process. Oh, it did the same thing again. Output. I have to hit a space after I put the word so it doesn't spell correct it. Process. output. Okay, and now I can take that whole big block and toggle it into a comment. Okay. All right, so let's look here. In housekeeping, what do we want to do? Print a polite message. Oh, and by the way, you can go and think this up on your own. You could pause here, see what pseudocode you come up with. Okay, so here we are. We're unpaused. Okay, so we're going to print a polite message. That's the housekeeping. Okay, and then we've got the input. Okay, well, what do we want now? Okay, well, we need the number of character strings. So prompt for n, the number of character strings to be entered. Okay. And then we could say get n. Okay. All right. And then in the process, well, if we do the same thing we did the last time, we've got really two things in the process. The first thing we need to do is we need to initialize our accumulator. Okay, so since we're accumulating strings, let's call it a string accumulator. Okay, so string accumulator gets assigned what? What's a good starting value for a string accumulator? Well, when we were adding, it was 0. When we were multiplying, it was 1. When we're concatenating strings, it's the empty string. So we're just going to put double quote. It's going to give it a string value that's empty, the empty string. Okay? Okay, and then what's the next thing we're going to do? Well, let's say we're going to loop n times. Okay, we're going to have some kind of for loop n times, and then we need the body. And we're going to say prompt for character string, right? And then we've got to get the string, okay? And then we have to, let's just say concatenate the string. Concatenate string. Well, we'll figure out how to do that with the code when we get there. Okay, now we've got these two things that are not comments. We're going to make those comments, give them a toggle. All right, get our stuff lined up again. Okay. And then on the output side, what we're going to do, well, we're going to print the concatenated character strings make, and then just put the string accumulator. Okay? Now, what's interesting is this is all pretty darn close to Python. Wouldn't you say? Okay, let's do some Python. So we're going to need a main. So def main, no parameters, give it a colon. Okay, and then we're going to have a call to main. I need to capitalize it. No parameters. Okay, that's it. And let's just go at it. Okay, so what's the first thing we do? We print a polite message. All right, let's do that. So we need to indent the code. We need a print and quotes, and the character string. Well, you know what? Let's just use the one we used up in our comment. If we did the comment well enough, we can probably copy it. It'll work okay. Okay, so that looks pretty good to me. And now that's testable. Let's give it a run. Concatenate a variable number of character strings entered by the user. I like that. All right, so what are we up to now? Well, we need input. So we need to do a combination of prompting for the number of character strings to be entered and then getting that. Well, okay, so we're going to put it in. Do we always have to use the value n? No, I don't think we do. So let's call it quantity. Okay, quantity equals, and again, we're going to have an eval on the outside and an input on the inside, and then the character string to prompt with there. So let's just say something like how many character strings do you wish to enter? Put the space on the end like we've been doing. Okay, that looks good. I'm just going to run a test again. How many character strings do you wish to enter? 6. Okay, it quit. Fine, that's all the code we have. Test as you go. It'll take you a whole lot. It's a whole lot easier to find problems when you just added 1 or 2 lines of code. Okay, so now we're down into process. We need to set the string accumulator to the empty string. All right, string accumulator equals empty string. Done. Okay, so this initializing the accumulator variable to something that makes sense for the kind of accumulating we're doing, this is classic. This is a very important pattern. And here, because we're concatenating strings, the proper initial value is just the empty string. Okay, and then we need a for loop. Well, I don't know how I did that. Oh, it looks like I'm continuing the string, and that's not what I wanted to do. So let me undo that. Looks like I was trying to continue the string value across lines. Okay, and so we need a for loop. So we want to say for. So do we want to call it string? String is a pretty common word. What's going to... How about we call it input string? For input string, in oh, I'm sorry. I've got it wrong. Never mind. That's not the input string. We need some kind of control variable for our loop. That's not where the string's going to go. Silly. Okay. So we need some kind of a control variable for the loop. A loop index. Well, let's just use I. That's the popular one to use. So for I in range n. Okay. So what's that going to give us? Well, that's going to give us n times through the loop. Now the value of I is going to be 0 through n minus 1, but do we care? No, we're not really using that for any part of the calculation. We're just using it to control the number of iterations. So that'll work just fine. You need a colon on that. Okay. Range n. Oh, did we call it n? I don't think we called it n. what do we call it? Quantity. Aha! See how that had the red underline? Quantity. Okay, range quantity. And now we need some code down there. All right, so what are we going to do? Well, let's get the input string. So let's say input string equals. Now, do we need to put an input inside of an eval? No, we don't. Because we're not trying to turn it into a number. We just want the string as a string. So we just say input. We say input, and in the parens we put what we want to prompt with. Okay. Enter character. Enter a character string. And a little space there, because that's how we do those. Okay, that's good. All right, and then let's just do 2 lines of code instead of 1. I guess we're doing 3 lines of code altogether, but we're doing this. Okay, so how do we accumulate it? So let's say string accumulator new value gets assigned string accumulator old value plus input string. And you might say plus isn't plus for addition, and it turns out that plus is just an operator, and operators can have a different meaning in different contexts. So it turns out that if the contexts are 2 strings, the operands are 2 string values, then the meaning is concatenate. Okay. If it's 2 numbers, then the meaning is add. When we have symbols that have more than one meaning depending upon their context, computer scientists say that we have overloaded them. So the plus symbol, the plus operation, is overloaded. It has one meaning when you use it with numbers, and it has another when you use it with character strings, and that's called overloading. Okay? All right, so that's good. So that's our processing. All right, so let's just try and run that, because we've got, I think, 3 or 4 lines of code in since we last ran a test. So how many character strings do you wish to enter? 3. And the first one, hi. The second one, mom. The third one, love. Okay, then that ended. Well, it seems to be taking them okay. So now we get down to the part of the pseudocode for output. So let's do that. Okay, so that's a print. And there was some kind of a message. The concatenated character strings make, I don't know, we'll just take that message. Okay, so let's just put that. And maybe we can capitalize the T for the. Okay, and then what do we get? Well, the accumulated value is still in the accumulator, so string accumulator. Okay, that's it, I think. Let's give it a run. So let's run it. So let's say 2 strings, hi and mom. Hi, mom. Oh, well, interesting. It put them right together back to back. It didn't assume that we want to insert a space in between them. It actually took the string that we gave and it just put them jammed right together. Okay, so how could we get a space in there? Well, let's run this again. Okay, so we could say 2 again, and we could say hi space, mom period. Okay, enter. Say hi mom. Or let's say we wanted to get proper capitalization on it, so then we could say run it again and say we want 2 again, and we could say hi comma space mom period hi mom. Wow, I have a capital I and hi. Well, you get the idea. Okay, will it work for 5 strings? Let's see. You know what? This is a good time to talk about what ranges should we test. Okay, well, we've tested 2. That kind of makes sense. Then I like to go considerably higher, right? So let's try 5. Okay. So how many strings are we going to enter? 5. And I'm just going to say 1, 2, 3, 4, 5. And it's all together. That's just what we thought. Okay. Let's run it and say 1. 1. So simple. We got simple. What happens if we say 0? Will it work for 0? 0. Well, it says the concatenated strings make, and then it shows us blank. Well, that's not horrible behavior. Okay. What happens if we ask for -1? It does the same thing. That's not horrible behavior either. So later on, we're going to learn how to test for invalid input. And then we could say, oh, that's not what we meant. Please put something in again. But for right now, that's not bad behavior for what we have. Okay, so I think we've adequately tested it. What do we have to do? Well, we need to clean it up. Let's get rid of unwanted code. So let's get rid of sorry, I don't know what we were doing there. Let's get rid of this pseudocode. Okay, so now that's gone. I went 2 blank lines up there. That's good. Okay, and let's run a code inspection on it. So code, inspect code. I have a suspicion of what it's going to complain about. No suspicious code found. Now, interestingly, this string accumulator line, when we're using this in terms of concatenation, it didn't suggest that we use the shorthand. Could we have used the shorthand? I believe we can. So I think we could have used the plus equal. There's even in most programming languages with this shorthand you can. So we could have said that. Okay, and then let's give it a test. How many character strings we want to enter? 3. And call them 1, 2, 3. And they come out 1, 2, 3. So we were able to use the shorthanded version of that, but interestingly, the code inspector didn't find that opportunity for us. I don't know why. Probably because it's only so good. Okay, so we've done that. We've done 13. We've tested it. We've inspected it. The thing, it is super pretty. It's ready to go. So I'm just going to do one more pause before I go on to number 14. Okay, we're back. And we're going to do the tutorial example for number 14. So the real question is, write a program that finds the average of a series of numbers entered by the users. As in the previous problem, the program will first ask the user how many numbers there are. Note the average, this should always be a float, even if the user inputs all ints. Okay. Well, let's see what we can do. We've got a program that kind of does something like that. That was at number 13, right? And I'm just going to take a leap here and say, I think I'm going to use that as a starting point and try to patch it up. Okay, so I'm going to right click and copy, and then I'm going to paste it on top of the project. Paste it. Okay, and it wants to know what I want to call it, and I just want to change it to 14. Okay, and it opens it up for me. Very nice. So chapter 3 exercise 14. Okay. And I guess what I want to do is I want to accumulate a bunch of things. I don't want to take the average. So let me accumulate a bunch of things and take the square root. Okay? How does that sound? So, let's see. So what's it going to do? It's going to sum a variable number of numbers entered by the users and print the square root of that sum. Okay, that sounds good. All right, let's see what else I could do. Okay, so it's not the average, but it's not too different. So that's our, that's going to be our message too. All right, that looks good. And let's say how many numbers do you wish to enter? That should take care of that. Okay. And we're putting that into a variable called quantity. That's still descriptive. Okay. Now, is it a string accumulator anymore? No, it's just a plain old accumulator. Oh, that's not good. So how do I change? I could change it here the first time I use it, but then I refer to it several times. Is there a way to change them all? There is, and that's with Refactor Rename. So let's just highlight the name of the variable that we want to rename. String accumulator. Right click on it. Refactor Rename. String accumulator. So let's just call it accumulator. So let's take what's on the back here. And these all work the same in all these programs. So it's just accumulator, and then you have to hit enter. So see, it's been changed to accumulator all these places. Very nice. Okay, well, we're accumulating numbers now, right? So let's give it the proper initial value, 0. Okay. And let's see. What are we getting from the user? Are we getting a character string? No. We're going to say enter a number. Okay, that looks good. Okay, is it an input string now? No. Let's say it's an input value. Okay. Oh, well then that made a problem with that. Okay, so I'm going to back up this. As long as you have 2 of them, you can use that Refactor Rename. As long as it, sorry, let me undo that. I don't know what in the world I've done there. Input string equals that. Yeah, enter a number. And instead of input string, let's highlight that. Okay. Right click, refactor, rename, and instead of string, let's get rid of the word string, put in value. You can see it goes into both places, then press enter. Okay, input value, let's go. So the next line makes sense. Accumulator plus equals input value. That still makes sense. And what do we want? Well, we're accumulating. We're getting a sum. All right. Now, do we want to print that sum? Oh, no, we want to print the square root of that sum. Okay. So let's do this in two steps. First, let's just print out the sum. Okay. Sum is accumulator. Okay? I think that's okay. So it should probably run. Let's give it a test. Okay, how many numbers do you wish to enter? Let's say 3. Enter a number. 1. Unsupported operand types for plus, equal, int, and string. Oh, that didn't work. Did it? So, where were we? We're on line 13. Okay. What did we forget to do? Well, we forgot when we went to string, from strings to numbers, that we need to wrap this in an eval function. We had been doing that all along before, but we had just given that up when we were working with strings. So we need to put an eval left paren and put the whole thing in a right paren. I think that's going to solve that problem. Okay. Give it a run. How many numbers do you wish to enter? 3. 1, 2, and 3. The sum is 6. Well, that's great. So the summing is going fine, but we're not done. It says the print the square root of the sum. Okay. Now, turns out I still have my documentation up for the math module. Okay. So in mathematical functions, let's see if we have something for square root. Power and logarithmic functions. I bet it's in here. Yep, right after math.power, we've got math.square root. Return the square root of x. So math.square root. Let's pull that over. Okay. So let's, first of all, let's say this. Instead of the sum, let's say the square root of the sum is that. So we're putting a good label on it. And then let's call math.square root. Okay. And put that around accumulator. And again, that would be working fine if we had imported the math module. Now, I'm going to take a flyer here. Let's, it says we have an unresolved reference to math. Let's click on more here. Well, it doesn't work. Let's see if we can highlight math and right click and can we get it to insert the import for us? Apparently not. Is it under refactor? Well, we're going to find this someday. In your typical IDE, you can just say, oh, I want you to do an import for that. Well, that doesn't work. So I'm hoping that there's a feature for that. Otherwise, I'm going to be really disappointed. So import math. Okay. And now our problem goes away. All right. So we know the summing works okay. So now we need to know if the square root works okay. So for me, it's a lot easier if I pick a number first. What I'm going to test with is going to add up to something I know the square root of. Okay, the square root of 4 is 2. So let's say we're going to run this and put in two numbers. Two and 2, they're going to add to 4, and the square root of the sum is 2.0. Okay, let's see if that'll work with 9. Okay, so let's run it again. And let's say we've got three numbers. 7 plus 1 plus 1. And the square root of 9 is 3. That's fine. Okay. Now, do we need, it looks, you can see that square root is giving us back a real number because it's giving us back a float. It has a fractional part. Can square roots have fractional parts? Well, the way I put this in, I never said these had to be integers, right? So let's see, for instance, let's run this and let's have it add up to 4.25. So let's say we've got 4 inputs, 1, 1, 1, 1.25. Yep. So I'm thinking that leaving it there makes this a more robust solution than it would otherwise be. So you might say, well, it's pretty hard to read all those decimal places, Kevin. We're really only interested around here in dollars and cents. So we say, okay, let's take that expression that it's currently printing out. Let's put that in a round. So let's put round. Then the first argument is the one that produces a number. And then we say comma 2 for 2 decimal places. Okay. And now I think we're just going to get 2.06. Let's see if we do that. Let's give it a run. And it was added up to 4.25. So 4 numbers, 1, 1, 1, 1.25, 2.06. Very nice. Okay. Now, did we have to round it to 2? No, it depends on what we need. If these represented dollars and cents, well, 2 would make a lot of sense. For your typical application, the number of decimal places we got is a little too messy. Okay, so that's a pretty good test. We've already done, since we borrowed the logic for how many things we're going to enter, I don't think we need to test that too much more. We tested the math of this. That seems to work fine. So I'm pretty happy with that. I do see up here where we have a misspelling. Sum of variable numbers. I don't know what that was supposed to say. Sum of variable number and print the square root. Okay, yeah, just get rid of that C. I think it had said compute before, so that's the one that got by me. And let's look at the code inspector. Okay, let's say code, inspect code. We want just the current file. That looks good. No suspicious code found. Okay. Now, it didn't find anything to improve about this accumulator plus equal input value because it already had the shorthand version. Okay. And that's what it was going to prefer anyway. All right, so that looks good. I'm just going to give it one more test. So I'm going to say the 5 numbers, 5, 5, 5, 5, 5. So it's going to go as 25, and we can see the square root of the sum is 5, which makes sense. Okay, that's it. So I'm hoping you're finding this inspiring. I just want to remind you, when you're going through these things, it's a good idea to pause before you see the way I set up the problem, and then just try to set up the problem yourself. Okay? Because we're trying to build that skill. All right. See you soon. Bye-bye.